The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
All right, ladies and gentlemen, welcome back once again, Season 2 of Future Proof, Episode 4. Today, we're going to dive into data science, and what a fascinating field this is. Well, in a nutshell, folks, data science refers to programs that have really managed data assiduously, I love that word, very carefully, and they built processes around that data to really understand what's going on in these organizations. Well, with data science, you practice really the ultimate challenge of data, which is dissecting vast amounts of information, gleaning insights, and then ideally patching those into your organization. And that last mile, folks, we call that taking something to production. And productionalizing algorithms from data science is a pretty tricky business unless you have the right technology to use. So today we're going to talk to Basil Faruqui of a company called BMC Software. They've been around a long time, and Control M, and how the Control M application allows you to manage data science workflow. That's really going to optimize value, and it's going to help your organization get that business value without reinventing wheels. So Episode 4 of Future Proof, Season 2, here we go.
All right, thanks, Eric. Appreciate it. So what I want to do today is really pick up from where Eric left off, is that, there's a lot going on in the world of data and data science. There's hardly any industry that is not taking advantage of or doesn't see the potential of taking advantage of data, not just for incremental business improvement, but really transformational. I think the word transformational has, because it's used so much, sometimes people forget what it means. I mean, transforming is not building a better mousetrap or doing something incrementally better, but transforming industries. But it is not without challenges, and I think a big focus of my talk today will be, what are some of the challenges when you think about operationalizing this at business scale? So with that, I first want to kind of start with an overview of what's really happening in the data world from, if we can quantify some of the investment in this space. So as you would imagine, there's an immense amount of money being spent on data. Here's, no presentation is complete without stats. So I'd love to just get that out of the way and start with stats. But these are some staggering numbers. The IDC is estimating that big data overall, and here they include services, hardware, software, everything, high double-digit growth, almost $190 billion last year. And machine learning in particular in this space is growing at a clip of 44% and is expected to be almost a $9 billion investment by 2022 by companies all over the world. So there's a lot being spent, but the results, to put it gently, are less than stellar. And stats can be interesting. Like my stats professor in grad school used to say, if you torture data enough, it will eventually confess. So you got to go beyond the face value of stats. But on face value, there's, as you can see on the screen here, Gartner's prediction is, or their estimate is, that only 15% of the use cases in the areas of machine learning, deep neural networks, will really be successful. Now, there's a lot of commentary in the market, and I work for BMC, and as part of my role, I end up spending a lot of my time with customers who are using our technologies, our software, to implement data pipelines and data and analytics projects. And what we hear is that, while there's a lot of money being spent, there's a lot of interest, where they're finding this difficult is getting it to production and operationalizing it. But you also got to take into account that even though the rate of success seems so low, companies realize that things may not work on first attempt. This is a big challenge, and they're going to continue to invest in it because they understand the potential. Now, some of the arguments around why the rate of success is so low is because this is complex business. This is not easy, not for the faint of heart, and complexity brings challenges. Some of them are really obvious. There's cost. This is expensive. It has become, the economics around machine learning have improved with the work that public cloud vendors have done. I mean, now infrastructure is really elastic. You can spin things up, spin things down. The cost of experimentation has gone down, but cloud also can be very expensive if you don't use that properly. Data governance, as people are on missions to build these massive data lakes, there's lots of security concerns, privacy concerns, but there's a lot of hidden challenges as well. And here I also want to take a minute and talk about kind of the relationship between data science and data engineering. Now, data science, which is fundamentally rooted in statistical analysis, and data engineering, which is more of building the infrastructure and the plumbing required to be able to take the work of data science and operationalize it. There's been some tension in between the two, and the tension has been like, how much of data engineering work does the data scientist need to take on? There have been many. This has been the topic of conversation in many data conferences over the years, and some estimates that 80% of a data scientist's time is often spent in data engineering and data wrangling, which has now given kind of birth to the idea of platform engineering, that maybe data engineering should evolve where it just builds platforms that can be consumed by not only data scientists and other stakeholders, more as a service. So I think some of these factors, when you start thinking about it, explain why the investment is so high, yet the results in production and operational state are relatively low. Now, amongst the hidden challenges, one of them is data pipeline and workflow orchestration. And if you've been doing data science and engineering for many years, and you're on to your 10th or 15th project, this may no longer be a hidden challenge to you. But large enterprises that are delving into data science, they may not see this as a challenge or something that they don't think about up front. But how do you take complex data pipelines that actually take data from ingestion all the way to analytics? That is often a challenge. So what I want to do next is talk about, well, what is this challenge? Let's double click into this. Now, before we double click into it, it's important to understand what does a data pipeline look like. You can take any data project in the world, and kind of the lowest common denominator in this space will boil down to four things. There's data ingestion from a lot of different sources. You got to be able to store and process the data. And the last and the most important mile is being able to convert that into insights. Now, the complexity in each of these stages can be quite daunting. I mean, just right out of the gate, if you want to do, for example, you want to get better at customer analytics, something that every company aspires at. I want to understand my customer better. I want to be able to predict customer behavior. Well, you're looking at multiple data sources that are systems of record. You will need to get data into your data lake from a CRM. You will need to get it out of maybe your customer service data, your support databases, your ERPs. And then you also are looking at lots of unstructured data that's going to come from social media feeds, maybe clickstream data from websites, sensors, cameras. As if the systems of records weren't mounting enough, there's a long list of these devices that can generate unstructured data. So right out of the gate, just being able to ingest data from multiple sources can be quite challenging, and it only gets incrementally or exponentially in some cases more difficult when you get storage and processing, because the number of, and when you think about this challenge. On kind of the right side of my screen here, I am painting this picture of what are all the different kinds of big data analytics driven services that businesses look to deliver. So there's personalized advertising, predictive maintenance, fraud detection. Oil and gas has huge interest in seismic data processing, so on and so forth. And in the middle is a complex stack of technologies that need to come together to be able to deliver this. And on the far left of the screen here, you see a number of different personas within an enterprise that need to work with these technologies to be able to deliver this. You have developers, you have cloud teams, you have database teams, you have your DevOps and SRE teams. Then there are stakeholders that you may not think of early in a data science project, such as auditors. You know, we had a very large media company out of Europe, and their big data project was centered around, targeted advertising on their platforms. And that hit a roadblock right before going live because the auditors came in and audited the project and said, you don't have the right level of auditing built into this, and we are dealing with customer data here. If we were ever externally audited and we were not able to produce the right audit trail, we would be in a world of legal hurt. So you have to be able to think about not just the technology and the use case you're delivering, but beyond just the data scientists and the data engineering teams of who are the stakeholders that you really need to be thinking about when you do this at scale. So when you think about, if I quickly go back to the previous slide for a second, oops, went one too far. When you think of this data pipeline and you think about how do I automate this process from start to finish, and one of the inherent challenges in automation here is that a lot of these different technologies that are in the tech stack here at every stage may come with their own built-in automation package utility. If you are familiar with Linux or Unix-based systems, you're looking at cron. If you're at Windows-based systems, you're looking at something else. If you're using Kubernetes comes with its own. So do the cloud vendors. So when you think about how do you automate the delivery of these services from start to finish, you're somewhat looking like a picture like this. It becomes very, very messy to orchestrate and automate this data pipeline from start to finish. And at BMC, the solution, the product line that I work for is Control M. And Control M's role really is to provide a layer of abstraction across all of these technologies, so you have a cohesive and single point of control for automating and orchestrating the workflows that power these digital services here. And what's important on the persona side is that it's important that the orchestration platform that you use is able to provide interfaces that can be used by different personas. What's going to work for a developer is not going to work for a business user. A business user is not going to be, for example, opening up Eclipse IDE to be able to understand what's going on with the workflow, whether things are on time or not, right? So that's really important, and I'll talk more about it. I think we'll have enough time where I'll be able to actually show you some of this in action in the demo. Now, another challenge, which is kind of not core to the whole problem, but is really, really important and comes up in an ugly way if not thought about properly. Large enterprises, businesses that have been around for a while, they particularly face this challenge. If you're a startup, this may not be an issue for you because the way you've set up your technology organization is already along the lines of DevOps and SRE principles. But traditionally, there's been a separation between developers and teams of schedulers and operators. And the way this has worked in the past is that developers are writing code, and at some point they hand it over to scheduling and operations teams. And scheduling and operations teams will look at this and say, well, you really didn't meet all our requirements. You didn't dot all the I's and cross the T's. Therefore, this can't really go into production immediately. You must now go and do some rework. Or, you've been testing your workflows with your own scripts and maybe some, free tools that are available to you. But what we use in production is Control M or some other enterprise grade automation orchestration solution. And now we need to do a bunch of rework because operations is telling developers that, well, you may have been working on this for 9 months, but we didn't know about this. So whatever you used doesn't apply in production, and now you need to do all of this rework. This is obviously very chaotic and inefficient because, as Eric mentioned, and as I mentioned as well in the previous slides, that the value of these projects to the business is immensely high, and time is of the essence. Walmart, I think it was a year or two ago when they started piloting what they called the pickup tower. If you're not familiar with it, the pickup tower is essentially a giant ATM. You can walk into a Walmart, you can order online, you can go to the store to pick up, and without talking to a human, you walk up to this pickup tower, scan your QR code or a code that you may have received over email, and the package will just come off a conveyor belt and you'll pick it up and leave. They piloted that in a couple of cities. I've started seeing them pop up in many stores nationwide here in the US now. But if you think about that project, when they were piloting that in 2 cities, they're obviously trying to compete with Amazon and other large e-commerce retailers. They cannot afford a 5-6 year timeline to get this done, right? So time is of the essence. And when you have, and you're a large enterprise and you have a working model where developers are working in a silo and operations is a silo, this is obviously completely the opposite of what the business. So it was really important that an operational solution, a production solution like Control M, is able to fit into modern release pipelines that operate on DevOps principles. So we exposed Control M through APIs so that developers can consume enterprise grade orchestration a lot earlier in the process. So that instead of going through handoffs manually with multiple teams, they're able to build the workflows that are going to power their applications in production, their data pipelines in production, and be able to run them through CI/CD tool chains. And an important point to make here is that we don't control the CI/CD tool chain. We just become a participant in one that you have. And the other important stakeholder is obviously the business user. There's a process owner on the business side, and they have a stake in understanding how these things are running. Are they going to be on time? Are they producing the results that they need to produce? And we made sure that there were mobile and web-based interfaces that business users can use to track the progress of their workflows. And as I get to showing you some of this later, it'll be a little bit more obvious. So while there's I talked earlier about how high the rate of failure was. Well, there is a number of companies that are also very successful with it, and that's exactly the reason why companies continue to spend a lot of money in this space. The first company I want to share with you is a company called Malwarebytes. Now, if you're not familiar with the company, their name kind of gives away what they do, right? They're in the malware detection, remediation, antivirus space. They're a relatively new company. They're a Silicon Valley startup that I think started in 2008, 2009. They're a pretty large outfit now. And they have an interesting business model. They have a freemium business model where they offer their software for free, and then there's a paid version for enterprises and the likes. Now, every time it runs a scan, it's sending data back to Malwarebytes. And there's lots of different uses for Malwarebytes with this data, but their primary interest in that data is being able to identify the new and emerging malware in the world. Now, the scale of just the volume of data is pretty interesting, that they ingest about 1.7 trillion data records per day. This is a 100% cloud-based architecture. So these records arrive and they have to process them through complex data pipeline with a number of different tools and technologies, in their case, all cloud-based. And they're applying very, very complex AI and machine learning models to be able to detect the new malware that's coming. They're only interested in the top 1%. So, they have to kind of look for the signal from the noise, and they're 99% of his noise, 1% is what they want to focus on because they're focused on the most harmful threats. One of the challenges they needed to address was this whole data orchestration challenge that I talked about earlier. How do you automate and orchestrate in a standard way from ingestion all the way to analytics? And they chose Control M for that, and they're now able to process 1.7 trillion data records in a 24-hour period in an automated fashion. And so you have a data pipeline that's end-to-end from ingestion to analytics. There are some other important operational characteristics that, everything that they're doing is time bound. Everything has an SLA. And Control M, when there's a problem, because their problems are also inevitable, these are complex pipelines, something will fail, something will be delayed, is not only identify where the failures and notify the right people or the right systems, but also be able to project in business terms that you've had a failure in the ingestion phase and you have 90 minutes to fix this. Otherwise, you will miss a business SLA with your customers. Okay. When you get a notification that has that level of information, that the actionability of that information is very, very different. And think about a situation where you have multiple failures. And how do you decide which failure or delay should you address first in a data pipeline? You may have an ETL job that has failed and a data ingestion job that has failed. Well, the orchestration solution, in this case, Control M, is able to identify which one of these is actually going to prevent you from finishing your data pipeline on time. Now, there could be a scenario where both are going to be problematic in terms of meeting an SLA, but providing business context to machine learning and AI is very, very important and crucial when you think about running this at business scale. Another area that they extended Control M to automating was their retraining of their models. Now, all the work that goes into building a machine learning or an AI model can quickly become, less than useful if the model accuracy drops. And one of the big reasons for model accuracy deprecating is data has changed and the model has not been trained on the changed data. So this is a constant and iterative process that they have to go through, and they had a team of data scientists where they constantly need to be provided, the new data, the new sources of data that they may be bringing in, and so that the models can be trained. And once the data scientists are satisfied with the accuracy of the models need to be redeployed back in production. They also extended Control M to automate this process so that this can be kind of hands-free and automated in this activity as well, which is, as you can imagine, extremely crucial in keeping the models accurate. The second customer that I want to share with you is a company called Rail Inc. Now, they're essentially the technology and IT service provider for all of the railroad companies across the United States. There's 140,000 miles of rail tracks across North America, and one of the services that they provide to the rail industry is tracking and coordination of real-time movement of millions of rail cars across the United States. And they have to be able to time the delivery of the cargo down to an hour. So all of this, as you can imagine, is driven by a complex set of data coming from lots of different data sources. Another initiative that they got into a couple of years ago was using the IoT sensors across the rail tracks as well as the rail cars themselves, and be able to predict any mechanical operational failures with the rail cars before that happens. Because when there's an emergency failure and emergency repairs have to be done, they're extremely expensive and disruptive. And we can all relate to it from our personal lives, that if your car breaks down in the middle of the highway, getting that repaired and towed is a lot more costly and disruptive to your plans than some scheduled maintenance of your car. So again, lots of different data sources, lots of different technologies that they're using to actually process this data. And the big challenge that they were faced with on operationalizing all of this was one of them was orchestration, and they used Control M to orchestrate data pipelines that feed data for about 1.6 million rail cars, and it's powering initiatives like being able to time cargo deliveries down to an hour and being able to do predictive maintenance on the rail cars across their fleets.
Wow. That's a good way to put it. And I'll throw out a closing comment and an open question for you to kind of tee off on here. What I see developing somewhat quickly now is that the disparity between leaders and laggards in just about every industry is growing almost exponentially, depending upon how you look at it. And what I mean there is companies that do not latch on to this kind of technology and start using it are going to lose laps and miles to their competitors, and that may not be retrievable. What do you think?
Yeah, I think we've seen that play out in many industries. Retail is a really good example. I think after COVID hit, we've seen some very, very iconic retailers go into bankruptcy. And arguably, I think the COVID was probably just a catalyst to that result. But the gap had been widening for a long time between companies that had been able to address their customers in a both online world as well as physical store. I think I read another stat. I love stats, right? I think it was the Hershey company that published this, that an average shopper in the United States takes 60 trips to the store between online and physical. So if you're a retailer, for example, and you want to address your customers, you've got to be able to be present in all of those channels. Otherwise, you're not relevant.
Yeah, that's a big deal, folks. The fun part is that you can get right to the meat, right to the interesting stuff, thanks to technologies like this. I'm sure Basil also remembers, because he pointed out how many different tools there are out there. And that's really the blessing and the curse of this industry, is you can use countless different tools, whether for automation or code development, different environments you can work in. It's a blessing and a curse, I say, because A, there's lots of options, but B, you could become overwhelmed by what's available. And by staying on top of which tool does what in which environment, which connects to which other tool, etc., again, which makes this kind of approach so compelling, because you want someone to manage that for you, right? You want someone to manage the single pane of glass that allows you to see into and across these very complex environments that include both data sources and technologies to manage the data, store the data, access the data, etc. It's just a very wild and woolly world out there. So to have some means of marshaling that is extremely powerful. Well, folks, we burned through an hour here. Big thanks to our presenter today, Basil Faruqui from BMC Software, and for them for allowing us to bring you this content free of charge. Hop online to insideanalysis.com for all the latest. And this is part of our Future Proof series. So this will be on TV later on this year. How exciting is that? Look us up, and if your local cable access channel doesn't have us, tell them to look into Future Proof. We'll talk to you next time, folks. Take care. Bye-bye.